I just wanted to welcome everyone to this webinar. It's going to be a presentation from Stuart Jennings, Dr. Stuart Jennings, the inventor of NutraFix, and he'll be presenting on a road trip he did to visit a lot of test plots showing efficacy of the product. Dr. Jennings, please take it away.
Okay, here we go. Wow, thanks for joining everyone. And this is a recent photo I took from the Paradise Valley south of Livingston, Montana. And it makes me wonder why the cheatgrass grows where it does. We've all seen these effects on roadsides, disturbed areas, but when it comes to a grassland and you see a perennial bunch grass in the foreground and the cheatgrass behind, my mind wonders, is this the extent that the cheatgrass will occupy in this pasture 5 years from now? Is there something about the soil that's keeping the cheatgrass out? Or is it just is the cheatgrass marching onward relentlessly to invade all of our western rangelands? And in Montana, we're not often thought of as the epicenter of the cheatgrass problem, but we have plenty of it here. So we're going to talk about that today, and we've been through some introductions, so thanks to everyone. And I would also like to thank some of my collaborators who I see are on this call. We've been working on this product for a period of years and collecting data. I'm going to focus more on the 2021 data. There are plots going back 5 or more years, and some of those folks are on the call, and I thank you for your willingness to be an early adopter or evaluator of this technology. Since there are people new to the product, I have a few slides in here you might have seen before for anyone who has been on some of my earlier webinars. I'm going to try to focus on data updates, and I have some discussion topics I will seed late in the call about climate, application rates, uniformity, species-specific responses, application timing, and then we'll finish with Q&A. For the NutraFix team, I introduced ACF West. They are a leading distributor of revegetation and erosion control products, and they are the manufacturer of the NutraFix products. So Brian, our moderator, is with ACF West. And the last slide in the show is contact information for those folks who may want to buy the product. Triton Environmental, they are Colorado-based primarily, and they are ACF West Colorado distributor, but they also have distribution channels for Wyoming. My company, Adafix, is an R&D startup with a mission to develop soil-based technologies for promoting the growth of desirable perennial plant species. And NutraFix is our first product, and it's licensed to ACF West. What is NutraFix? It is a specially formulated fertilizer with low levels of NPK and high levels of micronutrients. It is formulated to promote the growth of perennial vegetation and especially perennial grasses, allowing them to outcompete annual grasses. They're in reducing flash fuel loading on rangelands from invasive annual grasses and providing healthy forage for livestock and wildlife. So what do we know? We know that plants all require macro and micronutrients, NPK, as well as CalMags, sulfur, boron, copper, zinc, iron, manganese, molybdenum, and chlorine. And in particular, every plant has unique nutritional requirements. So if you're an alfalfa farmer, you would have a lot of phosphorus requirement, and you add potassium as your primary fertilizer, you may be getting disappointing alfalfa yields. Or the same if you're a wheat farmer and you primarily need nitrogen, and you have inadequate levels of nitrogen, you may not be making much money at the combining time at the end of the year. When it comes to weeds, we know less about what their unique requirements are. Central to that is that the NutraFix product is high in micronutrients, and weeds generally are unfavorable on micronutrients, whereas the desirable plants thrive on it. Essentially, I sometimes tell people you can't have an old growth forest without an old growth soil. I believe the same is true with grasslands. We can't have an old growth grassland without the old growth grassland soil. We can either wait 1,000 years for an inch of soil to form, and clearly that doesn't match with humanity's needs. So NutraFix is a way to invoke that late successional soil chemistry that is beneficial to the late successional plants that we want. In this show, we will talk about creating healthy soils through fertilization and also the companion benefits of reduced fire hazard and soil carbon capture. What would happen to this pasture if you applied NutraFix fertilizer? And on the ranch map, they call this their cheatgrass pasture because they have done everything to try to change it to perennial grass dominated. They've used herbicides, they've seeded, they've tried different grazing regimens, and they had a high level of frustration by their inability to convert this to some beneficial vegetation type. So they invited me to do a 20-acre test plot, and this is what it turned out like. So on the left, you can see last year's litter. So this is a year-old photo. So we put the treatment down 2 years ago. So this is essentially what it looked like in the first growing season. There's kind of a fun story that goes with this because the ranch manager had changed positions during the interim time, and he inherited the notes from the previous ranch manager. And there was a folder on cheatgrass fertilization. And he was pretty sure that had to be a typo because no reasonable person would add fertilizer to cheatgrass. And if you Google cheatgrass and fertilizer, you find there are plenty of publications out there where they say, no, don't ever add fertilizer to cheatgrass. Well, I will agree with that if I limit it to nitrogen fertilizer. Very few people dabble in the micronutrient fertilizer realm. Most fertilization is either nitrogen, phosphorus, or potassium. So grasslands commonly receive nitrogen fertilizer, which is only fuel to grow more cheatgrass. However, with the NutraFix product, we have the micronutrient heavy fertilizer, and the surprised ranch manager whose boots are depicted is standing in a perennial grass dominated grassland instead of the cheatgrass pasture. So when we went out to monitor the site, so those are cover frames for those of you who speak the Daubenmeyer cover frame management. So it's a 20 by 50 centimeter steel frame you see in these photos. So we have untreated above and treated below, and you can see there's a lot more green perennial grass in those treated frames than there was a year before. And the interesting question here is, where did all that vegetation come from? So if you look at the upper right-hand photo, it looks like that's all cheatgrass, but you see there are two white arrows, and you probably can't even see it at the scale of your monitor, but these are high resolution photos, and I zoomed in and I found that there were actually a few blades of green perennial grass that were growing in this pasture. So by adding the NutraFix product, we essentially awakened the existing perennial grass community that rapidly replaced cheatgrass as the dominant species in that pasture. So to be clear, we did not seed these pastures, but the plants, perennial plants, mysteriously came from existing roots, of which we were really happy. So thinking about this, so I'm a geologist by background, so parent material is one of my key frameworks that fits into the development of the NutraFix product. So essentially, to form soil, you need topography, climate, parent material, time, and organisms. And my point is, we can't really change 4 of these 5 things. We can change the organisms in terms of livestock grazing patterns, or we can introduce fertilizer that fuels the growth of microbes in the soil and fuels the growth of plants. While we have done a pretty good job of changing our own climate, that is something we can't change back to what it was. Parent material is something we inherit. So we have really very few tools to increase the rate of soil formation. So the soils in the Western US are 1, 2, 3, 4, 6 inches deep, and they contain 1 to 5% organic matter. And that is the magic that makes all the plant growth happen around the world. So again, following the geology thread, This is a picture of a folded rock structure called an anticline. This happens to be the Chestnut Mountain anticline that's close to where I live in Bozeman, Montana. And I show this because you can see the stripes of the rocks and the different vegetation types. I've always found that interesting how parent material controls the vegetation community that develops on it. So the shales generally have grasslands, the sandstones and limestones are generally tree covered or in combination with grassland and tree cover. So my question is one from a geochemical point of view is what is it about the chemistry of those rocks that controls the plant community development? So if you think about the Earth's crust, it is mostly aluminosilicates. The most common minerals are feldspars, and they're typically calcium or sodium silicates or aluminosilicates. So not surprisingly, the big pieces of the pie diagram are aluminosilicate minerals, but we also have plant nutrients like iron and calcium and potassium and magnesium. So they are present in percent levels in the soil. So if you look at the pie diagram to the right, it's essentially a soil pie diagram, and it's showing that in the organic mineral matter, which is 45% of this example, we have all of the plant macro and micronutrients. And in the organic matter fraction, the 5% green wedge, we have nitrogen. So most of the plant macro and micronutrients come from mineral matter. Nitrogen, conversely, comes from biological processes. So we mix those together with water and air, and that's what our plants have to grow from. So if we use iron as an example, and in this photo or in this table, it says iron is 5.6% of the Earth's crust. So in an acre of soil, 6 inches deep, you have 1,000 tons or 2 million pounds of soil. So if 5.6% of that was iron, how much soil iron would you have in an acre? And the answer is 12,000 pounds. And the reason I put this story in here is that there's probably only 1 to maybe 5 pounds of iron that's soluble in the plant, in the soil solution and available to plants. So essentially the plants are living in this mineral rich soil, but it's not available for their use. And the same is true of all the other mineral nutrients. If they're not soluble, the plant doesn't know they're there. It's kind of like water everywhere and not a drop to drink when you're sailing on the ocean. So the soil solution depends on how much precipitation you get in a year. So I'll pick a 12-inch precip zone as an example. That works out to 300,000+ gallons of water per year. So you take that mineral matter, you dissolve it into 325,000 gallons of water, or maybe I should say this is a 100,000 gallon year for many of our western rangelands, given the historic drought we're experiencing. And that's what the plants have to work with. So in a healthy soil, you have adequate fertility, you have adequate amounts of organic matter, moderate amounts of dissolved minerals, good infiltration, good water holding capacity, diverse plant community, deep-rooted species with carbon capture, and that's what we want. On the cheatgrass friendly side of this panel, we have the unhealthy soil that has lower amounts of organic matter and few nutrients and platy structure and poor water holding, and the early successional plant community, which means annual grasses in our case. And it means shallow rooted plants, and it means low carbon capture. So these are all the inverses of what we want. So the question is, how can we jump ahead instead of waiting thousands of years? How can we take steps back towards having the desirable plant community present? Which plant families are the winners in this depleted soil sweepstakes? So if you think about desirable rangeland plants, they come from many different plant families. So nightshades, legumes, mallows, onions, grasses, asters, mustards, others. So we have our desirable rangeland plants, And we have her undesirable rangeland weeds. So of interest to me is what are the rooting characteristics and what are the fertility characteristics in the soil that we need to have perennial grasses. You see the green circled desirable rangeland plant versus the annual grasses. It turns out that if you put a lot of nitrogen on, you are likely to get a bunch of annual grasses. So that's not going to help us get to where we need to be. And if we had more time, we could also talk about some of these other weeds like dandelions and salsify and prickly lettuce and knapweed and thistle, and because they also love these mineral depleted rangeland sites. So how do we rebuild our soil fertility to promote the late successional grass plants? Essentially, the essential micronutrients, mineral nutrients are highlighted on this periodic table. We're essentially going to think about the essential amounts required for each plant. So remember that varies by plant species. If you're deficient, the plants are struggling to grow. If you have essential amounts, that's what we want. If you have too much, it's toxic. So essentially, we have the perennial grasses needing higher levels of fertility, and not just nitrogen fertility, but micronutrient fertility, and the weeds ruling the deficient soil realm. So NutraFix is a way to move us from that mineral deficient situation to mineral enriched. So I thought I would throw in a turf example because one photo illustrates what I'm talking about. This happens to be a public park that they built in Bozeman, where I live, a couple of years ago. And they put out this beautiful new sod, and they watered and mowed it, and they haven't added any nutrients to this soil. Well, I should say the dogs have been adding some nutrients. So the green ring is our friend Fido gave us an example here of too much nutrients, in this case, urea or nitrogen. So there's a burn spot, and around that, there's a halo of dark green, nutrient-rich vegetation. It highlights that the rest of that turf, even though it received the same amount of water, is nutrient poor. And I can tell you it is also becoming enriched in weedy turf species. It's kind of the same way with rangelands. How do we create that nutrient-rich, healthy rangeland site that doesn't have too little or too much? So if this were a rangeland photo, cheatgrass would feature in the nutrient poor part of the photo. So comparing Adafix to conventional fertilization, essentially the NutraFix product has all of the macro and micronutrients in it. Conventional is nitrogen only. What does it do? NutraFix improves soil health. Nitrogen grows large plants. What's it made from? Minerals, naturally ground up rocks and a little tiny bit of manure in the case of NutraFix. And conventional is made from natural gas, so it's actually a fossil fuel fertilizer. And then the bottom line weeds, they thrive in that conventional fertilization regime, and they don't like the competition from the perennial plants when the NutraFix is applied. So to pick on one of my favorite elements, boron, NutraFix has an appreciable amount of boron in it. So I'm using southern Idaho as an example. The light colored rock type in the lower right shows the distribution of basalt in the Snake River Plain. And it looks a lot like the distribution of cheatgrass shown in red in the lower left. So interestingly, if you look at the amount of boron in igneous rocks, so basalt and granite, they have typical boron levels around 5 parts per million. The Earth's crust has an average of about 11. But then if you look at the marine sediments, sedimentary rocks like limestone, sandstone, and shale, they have appreciably higher amounts of boron. Not coincidentally, they have lower levels of annual grasses. Not surprisingly, the NutraFix product has appreciable amounts of boron in it to help convert the soil to a condition that is suited to late successional perennial grasses. So essentially, we are trying to take, in this hypothetical example, we're going to try to take the nutrient level in the soil solution from 5 milligrams per liter to 10 or 15 milligrams per liter, where our desirable native plants will grow and the weeds won't be so happy. So my fundamental approach is that these healthy grasslands need all the macro and micronutrients. And then from a management point of view, one of the questions is, how long does this product last? That relates to how you manage the property. Let's say we could restore all the rangelands in the Western US to a healthy plant community. We would be faced with the next question is, well, how are we going to manage them? If we manage them the way that we have over the past 100 years, they would probably just revert back to annual grass dominance, because we have created the perfect soil for growing annual grasses. So we want the soil that the annual grasses don't like, and that includes that dark, rich A horizon. So we want to grow deep-rooted native plants that sequester carbon and cycle nutrients and keep the annual grasses at bay. We're talking about a tiny wedge of the pie diagram. So if you compare a healthy soil to an unhealthy or depleted soil, you'll notice that little tiny black micronutrient wedge. It's the sum of all the macronutrients. So it's not just iron, or it's not just copper, or it's not just boron. All the micronutrients summed together are just a tiny, tiny fraction of what plants need. So the assumption is they're always present at adequate levels without fertilization. And I'm here to tell you that that's true if you want to grow cheatgrass. If you want to grow late successional, desirable plants, you have to have the soil chemistry that matches with what those desirable plants want. I would like to talk about data that I've collected this spring with others and some of the sites I visited. This road trip to look at a variety of test plots in Utah, Colorado, and Wyoming are included in the next bank of slides, as well as some Montana examples. So starting with Utah and Colorado combined to use a common experimental design. So they use 4 replications of 3 different rates of the NutraFix product. So we have a total of 10 sites. Those were put out last fall. So the preliminary data collection is going on now. So we'll have that data late in the fall or next winter. I don't have that data to present today, but we did go to several of those sites. To start with one, this is an older site that was implemented in 2019. And this is an interesting site. And I have another picture later in this presentation to talk about seed bank. But I like this because it shows that blue bunch wheatgrass and alfalfa are growing next to struggling cheatgrass. So this is a treated plot. It shows the conversion of this annual grass dominated site into perennial grass dominance as the annual grasses are reduced in prevalence. Going to another site in Utah, this is Mighton in the Uinta Basin. This is an oil and gas reclamation site. These plots were also put in 2019, and things have been difficult there because it has hardly rained since then. The only place we could find where cheatgrass had germinated was on the downwind side of a sagebrush plant where it looked like there might have been a snowdrift. Moisture is critical, so the treatment is in the ground, and I'm optimistic that when the rains come, the treatment will work. Absent of rain, there is a very limited forage on these sites. Going to Western Colorado, this is a study put in by Colorado Parks and Wildlife. And if you look at the upper left photo, you can see the Adafix treated plots are dark green squares. In this case, we're comparing the fertilizer NutraFix to the plateau herbicide for control of cheatgrass. There's also seeding and pitting in this experimental design. And I love this photo because it shows that the Adafix plots are green. There's a little bit of a lie built in here, and I'm a preacher's kid, so I can't perpetuate it. And that is that we didn't actually grow the seeded species in the first growing season, which was 2020. We actually grew Russian thistle. And so while I don't want to be the proponent of that as our desired outcome, we took the long-term view and crossed our fingers and hoped that would be an early successional step towards replacing cheatgrass. And it turns out in the spring of 2021, the elk found the plots first because the cool season perennial grass is germinated, and the elk showed up and found them to be extraordinarily delicious. And they were only present on the fertilizer treated plots, and they ate a good amount of our cool season plants we grew. So while I'm thrilled to have the elk endorsement, who knows what those plots will look like next year after that herd of elk descended on our treatments. The good news is that we have greatly reduced cover of cheatgrass in those plots, as well as bulbous bluegrass. So monitoring has occurred on these sites this summer, and the drought is going to be part of that story. And I'll have that data in a subsequent PowerPoint show. So going up to Wyoming, researcher there with the University of Wyoming installed plots in 2020 as well. And remember, our quote unquote standard rate is 350 pounds per acre. So what he did is a 2x, a 4x, a half x, a quarter x, and 1/8 x that standard rate. So that worked out to 4488, 175, 350, 700, and 1400 pounds per acre. So he set this up as sort of a dose response toxicity study. He installed replicated plots at Sheridan and also at Laramie. And there were clear treatment effects when I was there in April. Here's an example of some of these adjacent plots. The plot we're looking at here is a control plot where the dry erase board is in the middle of the plot. These plots are 10 feet wide and 30 feet long. On the right-hand side, we have the 1,400 pound per acre rate and 700 pound per acre rate on the left. So you can see there are very big differences in the treatment response. And just so I say it out loud, the 1,400 pound per acre rate is the highest rate I've known of that anyone has done. And that's not the recommended rate, but it is really instructive to see what happened in that high rate. So to go to the standard rate, here is what 350 pounds per acre looks like. That plot is dominated by bunch grasses. You can kind of imagine that you're seeing some bunch grasses rather than a carpet of cheatgrass. And to my eyes, I see a little darker green foliage compared to the lighter colored cheatgrass. But this is what we want to see in the first growing season. They will monitor these in the coming years, so this data will be forthcoming. One of my favorite photos is the photo of the 1,400 pound per acre rate, because there are two species that are still growing, and that he called it the cat litter rate. He said it was so much fertilizer on the surface, it looked like a litter box. Smooth brome and crested wheatgrass seem to be totally fine with that high application rate. The crested wheatgrass looks a little yellowish, like it may be stressed, but the smooth brome looks entirely happy with that really high application rate. So jumping to Montana example, this is a ranchland site near Bozeman where we put plots out last spring and last fall. So we have a comparison of spring application and fall application. So the upper graph shows the amount of annual grasses, the lower graph shows the amount of perennial grasses. So looking at the annual grass cover to start with no fertilizer added, we had 40 to 50% cheatgrass. If you look at the series as a group, the green series is spring application. So there is more cheatgrass in these sites that were treated in the spring, and the maroon series that are generally less than 10% cheatgrass cover, those were fall applications. So based on this graph, if you had your choice, I would choose fall application. And especially at the 175 pound rate, we had about 10% annual grass in the fall application and about 30% perennial grass in spring application. So really prominent difference between spring and fall. Going to the bottom panel, the perennial grass covers spring versus fall. We had less than 5% perennial grass in the untreated sites, and generally 5 to 20 or 25% perennial grass in the treated plots. The treatment worked as intended here, and the next photo shows an example. So this is a cheatgrass pasture again. And I like this photo because Western wheatgrass, as many of you know, has that bluish hint, and it loves this fertilizer treatment. And the annual grass, in this case, all cheatgrass, didn't love it so much. And it's clear outside the plot how effective the treatment was after fall application. So I'd also like to talk about ventenata. There are 3 major annual grass problems in the Western US, cheatgrass, ventenata, and Medusa head. I have not done any Medusa head work, but I put some plots out with some collaborators last fall in Joliet, in Bozeman, and in Sanders County in Northwest Montana. And I have data from Joliet and Bozeman, and I have a verbal from the Sanders County example that the plots were effective there. Starting with the Joliet site, put these plots out with NRCS, and I know my collaborators, Cedar and Crust, are on the phone, so thank you for helping get these plots installed. This is the 500 pound per acre rate. This photo is from June. And to get you oriented, the ventenata at this site is yellowish in this example. Western wheatgrass, again, is the dominant perennial inside the treated plots. And there is one giant, strange looking plant in the middle of that plot that is alfalfa. And the rancher came out and begged us to make more of her alfalfa grow at that stature because all of the alfalfa plants in the adjacent hayfield were comparatively smaller. So she was really happy about the outcome. This 500 pound per acre rate is a higher rate than we would recommend, but it's helpful in terms of a research application because we can look at a broader range of application and the plant community responses. This is what the plot boundary looked like at that 500 pound per acre rate. So you can real clearly see the yellow ventenata outside the plot and the litter from the ventenata the previous year, now flat on the soil and gray in color inside the plot. So this is the closer to the standard rate. This is the 333 pound per acre rate. And there is still about 10% ventenata in this plot. I'm optimistic there will be less next year. At the 167 pound per acre rate, the amount of ventenata jumps up to about 25%. So you can see the yellowish tint, the kind of perennial grass, bluish green with the yellowish tint of the ventenata in this plot. So this treatment did not look quite so promising. The winter was dry enough. We still had undissolved fertilizer on the soil surface in the spring. So I'm optimistic this plot has the potential to get better next year, but we still had about 25% ventenata in that plot. So at the Bozeman site, I made quantitative monitoring measurements recently. This is on ventenata again. So with perennial grasses, let's start with the fertilizer application rates. The same ones you just saw from the previous series, 167, 333, and 500 pounds an acre. Annual grass cover went from essentially 18% in the untreated to 2%, 1%, and less than 1% in the treated plots. So the 167 pound per acre rate was actually better on the ventenata here at this site. The perennial grass cover is the inverse. On the untreated, we had 5%, and on the treated, we had 4, 10, and 13%. A good first year result. Here's a photo of one of the Bozeman sites. This is the 333 pound per acre rate. And that dark green grass in the middle of the plot is smooth brome. We talked about smooth brome at the Wyoming site, how happy it is with this fertilizer treatment. Well, turns out it is very happy here as well. So I'm down to my final slides now. So you're into the final stretch of this presentation. I want to hit a few key points. One is that these plots get better over time. So using an example from Southwest Montana, this is monitoring done by Montana Fish, Wildlife and Parks. We put plots out in September of 2017, at which time there was 67% cheatgrass and 23% perennial grass. And you can see in the following 3 years, the perennial grass, and these are averages of several plots, which is why those lines look as straight as they do. But the perennial grass just improves every year and the cheatgrass diminishes every year. And by the third growing season, we're down to about 11% in those plots. So another key point is seed bank reserves may be important. If there is no desirable seed in the seed bank, you're not likely to have the bloom that we had at this site. This is from that Utah site I showed you earlier, and it has a similar trend on perennial grass and annual grass with increasing application rate. But the really remarkable thing that happened here, and this is at a site where there are some herbicide trials as well. Maybe the lower right example is the best one because you can see the untreated on the left with the heavy cheatgrass cover. And then after application of herbicide, it's mostly broom snakeweed and false dandelion, and maybe a few percent desirable perennial grasses. And the NutraFix sites were startling to everyone, myself included, for how well they did in the first growing season because they became invaded by blue bunch wheatgrass that we did not plant. And so the manager at this site thinks that seed may have been in the soil for 10 years. Or maybe those plants were still present and we just couldn't see them underneath the carpet of cheatgrass. But we had an incredible change in this plant community to this blue bunch wheatgrass dominance that we're all excited about. Application timing is something I wanted to mention. Since it is a fertilizer and it's slow dissolving, you can put it on at any time of the year, but really we're coming into the ideal timing now, like August, September, October. Those are the best time to put the products out because that's when the cheatgrass germinates and when the perennial grasses grow in response to fall precipitation. So our best window is coming up in front of us. I can't have this presentation and not talk about climate. We are in a bad and changing to desperate situation with moisture. There's nobody on the call that doesn't understand this challenge. As it relates to the NutraFix product, you can see in the right-hand example, this was a cheatgrass plot I monitored last week, and you could still see some of the fertilizer grains undissolved on the soil surface. This is actually kind of a good news, bad news story. If none of it dissolves, you're not going to have any plant response, so that would be bad news. The product is actually formulated to include some slower dissolving mineral phases. So this is our intent with the NutraFix product is to try to have it persist as long a time as possible in the soil because the annual grass seeds are often have a lifespan of say 3 to 5 years. We'd like this treatment to last for 5 years or so. Another key point, so this is a new slide nobody has seen before, but we're seeing some differential sensitivity in our monitoring by plant species types. So in the left side of this panel, I have fertilizer rates from 100 to 1,000 pounds an acre, and I called the 1,000 pound an acre rate extreme. So our standard rate is more like 300 pounds, but even at those extreme rates, we see western wheatgrass and smooth brome growing happily. But one thing we have noticed is in sites with fescues. I saw Franz is on the call. We have a site with both rough fescue and Idaho fescue, and we're seeing more and more sensitivity. So if you have an Idaho fescue dominated site or a rough fescue dominated site, something on the lower end of the application rate would be best for that community. One of my favorites, blue bunch wheatgrass, seems to grow well, even in high application rates. We have seen some bluegrass stress, and the bluegrasses are kind of interesting in that I was at a site last week that had Canada bluegrass, Poa compressa. It really was growing well in 500 pound per acre rates. But if you look at, say, Kentucky bluegrass or Sandberg bluegrass, it seems to do better at rates more in the 200 to 300 pound range. Prairie sandreed is one I thought I would mention. That's a warm season native grass. And I had some older plots I looked at this spring, including a rate that I think it was 87 pounds an acre. And the prairie sandreed was only found in those lower treatment plots. And interestingly, it wasn't even found in the offsite control. It just loved that low application rate. So there is a bit of species related variation in which species like which application rate. Native forbs are kind of a tricky one because there are so many native forbs. In general, they like the NutraFix product application and the Weedy forbs. It varies a fair bit among that family of Weedy forbs, which ones like it and which don't. But that's a subject of another webinar. In particular, the cheatgrass and ventenata, of course, does not like the higher application rates. So any of these treatments are going to help. And there's a bit of design around what is the best rate to use for your plant community. Another thing I wanted to mention is uniformity. So this is a plot I monitored last week. The results are in the lower right. It's similar to what we have seen in some of these other data. But one thing interesting I liked about this plot is that you can see the arcs from the fertilizer application in this plot. So everything that's tall in this photo is cheatgrass. And I think that the uniformity of application was not great at this site. And so we have these arcs of cheatgrass where there was either no application or under application of the treatment. So I tell people when they put the product on, try to put it on as a half rate application in 2 perpendicular directions to try to get uniform cover. So in conclusion, it actually works. It is effective. It's made from naturally occurring minerals. It's easy to apply. It's long lasting. It's cost reasonable, however, not cheap. It restores soil fertility. It is seed friendly and promotes the growth of perennial grasses. And there had been a question earlier about how to purchase. Essentially, Triton is the Colorado, Wyoming distributor. ACF is the distributor for everywhere else. We can get you mapped through any of these people because they're all mapped together as a team.
Well, thank you, Stuart. This was really fun to watch. A lot of new slides, a lot of new information. It was really, I learned a lot. Carrie asked, is the product primarily used on dry pasture land, or can this product be used in irrigated land? She also said that cheatgrass is discussed a lot, but what about knapweed? Her irrigated pasture is an issue with knapweed and foxtail.
So can this be used in irrigated pastures? Yes, I have limited experience working under irrigation. I have worked mostly on turfgrass weeds, so like dandelions and clover in Kentucky bluegrass under irrigation. But the same principles we're talking about here are just accelerated by irrigation because you can kind of invoke your climate rather than waiting for it to fall from natural rainfall or snowmelt. The question about foxtail, I have not worked on foxtail. The question about knapweed is that is still an R&D area. So we do not have a product out for knapweed. rest assured, I'm working hard, and there's some promising findings for some of the other noxious weeds that we all know and don't love related to the same strategy.
Well, thank you, Carrie, for that good question. We have a new question in from Steve Hale to all panelists. Can NutraFix be applied to areas that have been heavily treated with herbicides for cheatgrass? So kind of, how to kind of follow one with the other.
Yeah, thanks for that question, Steve. The answer is yes, and that's a common herbicide challenge, is that, let's say you're spraying for knapweed, as it is often the case, you want to make sure to kill the knapweed. So you put on a sturdy rate of application, and a year later you have no knapweed, but you've also injured your perennial desirables, and then the cheatgrass comes in. So the question is, how do you balance the use of herbicides with the annual grass and control? So yes, you can use these together, and there also are cheatgrass herbicides that can be used. And I see that Shannon from Bayer is on this call. Clearly, Bayer has an outstanding product in their new Rejuvera product on cheatgrass. So if you're using herbicide, there's a knapweed cheatgrass herbicide strategy that could be employed as well. And what's one thing I didn't say in this presentation, I probably should have, is that there are 100 million acres of cheatgrass, and NutraFix is an outstanding product and works well. But there are other strategies out there, and my goal is to have a big toolbox with lots of tools in it, and not to say that NutraFix is the only product you can use. With any repair job, it's better to have the deep bench depth in terms of different options rather than being limited to one option, because there are things that NutraFix does better than the herbicides do as well.
Another one from John. How is NutraFix used in conjunction with seeding, both hydro seeding or drill seeding?
Yeah, so my view on seeding is that is something you can do and does work. So thinking about the plant sensitivity graph that I showed, many of these plants are fine. Let's say if you're seeding Idaho fescue, that was one I made a fuss about. If Idaho fescue is in your seed mix, and that's an important component of the re-veg mix, I wouldn't use the standard rate. I would use a rate of about half that much. My general broad recommendation is with seeding is to use a rate more in the 175 or 200 pound an acre range, more so than the 300 or 350 pound per acre range. But we have seen great responses to the seeded species. And one thing that really helps is that you often get a lot of cheatgrass in either hydromulch or drill seed applications in that first growing season. By having the fertilizer in there, it promotes the growth of the seeded rather than the weedy species. So those sites have tended to have less cheatgrass in them. But as an overall, I would just dial the rate back a little bit. With respect to hydromulch, you would have to have a nozzle on the gun that was big enough to accommodate the fertilizer grains. And I'm no expert on hydromulching, but the product is, some of it is insoluble enough, it's likely not to dissolve in the tank. So you would be spraying it as a granular product out as part of the hydromulch application.
Laura Finch from Triton has raised her hand. So Laura, if you'd like to unmute and jump in, please do so.
Wonderful. I just wanted to say thank you, Stuart, and ACF West for putting this on today for us all. But also wanted to say that I have a couple of projects that have either started or gone this year, and some that are going to go in next year. We're doing the 350 pounds an acre of the NutraFix in a reclamation scenario, along with macronutrient fertilizer and biotic soil amendments. So we'll have a great view on what that application rate does in the coming year. Give it a year from now, and we'll be able to get some good feedback on how that rate is working in some test plot scenarios.
One quick question, Stuart. Is there any application technique that you would recommend to get this NutraFix product down underneath the canopy of heavy sagebrush?
I think all of the broadcast fertilizer methods work well, because the the fertilizer is heavy enough, it just kind of rattles through the litter and ends up on the soil surface. One of my least favorite ways of, and an ever more common way, is to have fire burn off the canopy, because it's the dissolution of the product requires rainfall. And I think if you have heavy litter, it may slow down, especially in a dry climate, how fast the product dissolves. So sagebrush is not really a problem. It's more like it's a challenge for the herbicides as well. As any kind of heavy litter buildup is a challenge. But the fertilizer, I think, is the best because it's heavy enough. It just tends to go through all that litter and ends up on the soil surface. So agricultural tractor with the spreader, or you saw that hopper cart I had in that earlier photo with towed by the truck, that works fine. Though, if you're in very big sagebrush, you may need a bigger piece of equipment to get around in that heavy sagebrush cover. And also uniformity is a little bit of a challenge in that, like that pinyon juniper sagebrush country is trying to, not have over and under application, because it's not like a farmer's field that you can drive around in with a tractor.
Well, we'll have some good examples of hydroaxed areas where they've actually mowed down the sage and some small pinyon juniper areas, and we can apply now on top of that, and then
Great.
virgin ground as well. So we'll have some good comparison.
Fantastic. Thanks. That should be a great example. Well, great. Thanks to everyone for participating, and thanks for moderating, Brian. And feel free to reach out to us by email if there are any questions.
Thanks again, Dr. Jennings. Appreciate it.
Okay. Until next time.
Bye-bye.
Bye.